Now, why am I telling you all this, apart from the fact that I think it's cool? To have a piece of air that's 800,000 years old. But you can also have pieces of air that are 750,000 years old, and 700,000, and 650, going all the way back. If you can go back, if you can drill all the way back down, if you can get pieces of air from all the different parts, what you can do is you can look at that air and you can say, what does it have in it? And what it has in it is very interesting, because you can find bits of oxygen, which is always there in air, or has been for a very long time. You can find pieces of nitrogen, which is the big kind of bulky thing that's in the air that we breathe. But you can also find tiny little bits of this same gas that I was just saying made all the difference on Venus. Carbon dioxide. And there's two other gases as well that you can find in it. Does anyone know what this one is? This is called nitrous oxide. That's N2O. This is carbon dioxide, carbon and two oxygens. And this, anyone know what that is? Yeah? It is methane. Really well done. You guys are good. So these three gases, carbon dioxide, nitrous oxide, and methane, all three of them have this almost magical property that when you put them in air, they make it warm up. It traps heat from the sun, and they're called, anyone know what they're called? Yeah? They're called greenhouse gases. And greenhouse gases is right now what everything is all about. Okay, so let's think a bit more about what these greenhouse gases do. First of all, carbon dioxide. So we have been putting carbon dioxide into the atmosphere just over the last about 150 years at an incredible rate. Right? So what I wanted to do now is just try and understand where that carbon dioxide is coming from. So first of all, this is one of the places it's coming from. So what's this? Yeah? So this is actually a petrol pump. So this is petrol going into a car, burning petrol to drive planes, cars, burning diesel to drive trains, is one of the ways that we've been putting carbon dioxide into our atmosphere. And going back, just as we did to that ice core, looking at the different layers of the years, you can find out that you can go back 800,000 years and you can never find the same high levels of carbon dioxide that we've got today. So it goes a bit low, it goes a bit high, it goes a bit low, it goes a bit high. And when you get to the present day, it suddenly shoots up. Shoots up. So this is one way that we're doing it, we're burning petrol. Another way, what's this? Yeah? Yeah, up there? It's coal, burning coal. This? Yeah? Deforestation, burning down trees. Burning down trees is also putting a lot of carbon dioxide into the atmosphere. This, what's this? Yeah? Burning gas, burning natural gas. These are the four main ways that we have, over the last 150 years or so, been increasingly burning coal, burning oil, burning natural gas, and burning trees. And we're doing it at an incredible rate, and we're putting vast amounts of carbon dioxide into the atmosphere compared to what there was before. Then, of course, you have this lovely lady, Daisy. You have cows. Now, first of all, what are cows responsible for? Yeah? They're responsible for methane, natural gas. So this is the next one of those molecules, not just carbon dioxide, but methane. Cows actually belch a lot of methane, all right? And there are other ways that we're increasing the amount of methane as well, because when we try and pull natural gas out of the ground, before we burn it, some of it escapes as well. So that's the way we get more methane. Nitrous oxide we get from agriculture, from fertilizer. So what I'm telling you now is we're starting off again with a planet like this. We have water, we have a relatively comfortable temperature, we have lots of food, we have lots of beautiful places to go to. But in the last 800,000 years, in fact, in the last 150 years of that 800,000 years, we've gone from having a planet which is very much in balance, which is fairly comfortable, to just lately putting carbon dioxide and methane and nitrous oxide into the air at such an incredible rate, we're on our way to Venus.